Hey guys, welcome to this extra part of our TransCAD tutorial 5. I'm Danny. In this part, we're going to do transit assignment, which is like traffic assignment, but with the root system. So I'm going to work the workspace in the tutorial file with the name transit assignment. Here we have the same Momata example. And here we have the transit network file defined already, and we have from previous steps we have this OD matrix for transit generated. So now our task is to assign these OD trips into our transit system, so that for each OD pair we know where they are going, which route they are using. So to do that is very easy. We simply go to transit with the map being active, and we go to transit assignment pathfinder. Here we can just keep this input with the input in the options also by default, and just click OK and override the files. And it's finished. So we have many tables generated. We can have a look at them. So first of all, we will have a joint table with the flow aggregations added to our link layer. So this table on the left is our links, and on the right we will have the flow from transit assignment added. So here we can see most of them are empty, and here we have a link that is not empty. And we have a look. If we right click on it and zoom in, then we will come to the link, which is this one. Here we can see it says the AB transit flow and BA transit flow, which are the flow of transit of the two directions of this link. They are 0. And the AB and BA non-transit flow, they are not 0. So this is our link. We can confirm that by in the table, the ID of the link is 16118, and on the map, switching to the link layer, we use the info button. So this link, 16118, if we zoom out a little bit, we can see that it is this link connecting this centroid zone, centroid of the zone, which is in this workspace marked as a blue star. So our link here is a connector link connecting the centroid to a node. And here it seems that this is the closest station. So then the reason is very clear why for this link we have 0 transit flow, because we have no transit route going over this link. And these two, the non-transit flow, there are people walking from or to this centroid via this connector link. Another example would be this link right beside it. If we zoom, it's just this one, just near our first link here. So this link, the transit flow will be non-zero because we have trains going over this link. And also the non-transit flow are not 0 either. And if we zoom out again, we can see probably the trips from or to this centroid would go via this link, and then this link we are looking at, and then to or from this nearest stop. So we can actually check the numbers. For this link right here, the non-transit flow is 777 and 1300 for the two directions. And if we come to the map and look at this link, the non-transit flow are exactly the same, right? So they are from two links. So it proves our guessing of that the non-transit flow of this link all come from the link here and originally from this centroid here. So that's the result of this table. And we can also look at the result of other table. Here we have a transit flow. And what's different from this table to this table we have just looked at is that this straight joint table, it's a table of all the links. But this flow table, each row will not be a link on the map, but instead it will be a segment of each route separated by the stops. So for example, for route 1, we have these 12 segments, and it shows from stop 1 to stop 2, the flow is as such, and also a lot of other transit related things like dwell number, in-vehicle travel time and cost. So we have in total 20 routes, so we have segments for each of them. So as a result, we have 140 rows only for this transit flow table. With this table, we can do some visualization. For example, let's now hide the other layers just to make it clean for ourselves to see. The transit flow is actually generated as a layer onto our map. So here, if we even hide the route system, then we can see these transit flows are generated just like segments of shape files. And their properties here in this table. So we can do like a thematic map or a size themed map. Let's say we'll do color theme using the transit flow, which is this field here. And let's say the low flow will use green and the high flow will use red, and apply. So now we can see inside the transit system which segments of which routes are rather busy while the others are rather idle. We can also use the size themed to visualize the same field. Just apply, and here with the thickness of the lines we are expressing the same thing. Kind of redundant, so depending on which you like. So if you like both, you can keep both. If you like only the size, then you can remove the color like this. So that's just a visualization. And next we can look at this table, the boarding counts. So this table is generated for each stop. We have the number of like total on and off, which is the sum of the walk access plus transfer. For example, for let's say this table, this stop here, total on is 585, and one of them is walk access on. That means a trip from some centroid, and that person walked via some links and then come to this stop and get on. All the other 584, they are from transfer, so they come from another route. Similarly for off, so you can check all these numbers, and we have egress right here. So this results will be useful if you're doing some analysis for your transit system. So there are other tools you can explore once you finish your transit assignment. There are more visualization analysis tools. So we're not going to cover them today. So that's all for this extra part of the tutorial. Thank you.